logarithmic functions. The objectives write equivalent forms for exponential and logarithmic functions. Write, evaluate, and graph logarithmic functions. We have been studying the exponential functions, so we know how to calculate inverse functions. What we are doing today...
Please pardon the interruption. Would Andrew Cosby please come down to the technology office with your laptop? Andrew Cosby to the technology office with your laptop, please. Thanks.
Okay. So what we are going to do today is to find the inverse function of the exponential function. That's it. We give a name, and a special name for this inverse function, which is the logarithmic function. That's the only thing, so don't be afraid. I know that is a name very new for you, but let's see. The vocabulary, logarithm, we will have the first definition, then the common logarithm is a special case of the logarithm. Also the natural logarithm is also a special name of a different kind of base. And the logarithmic function, we will graph the logarithmic function having some points and then by using the equation. So let's see. The previous concepts. This week we studied the exponential function and also the exponential equations. Let's see something that we did in GeoGebra for this class. Let me see here. Look at that here. We have the exponential decay and the exponential growth. Let's see the value of b. Value of b is 0.7, look at that. The value of b indicates, which is the base, indicates an exponential decay. If the value of b is greater, like in this case, 2.3, y is equal to 2.3 to the x, gives you an exponential growth. Question, is this function a one-to-one function?
Yes.
Remember the pencil, horizontal pencil?
It is.
Touches one time. So this is a one-to-one function, therefore we will be able to find the inverse function. But how to solve for x? We don't know how to solve for the value of x.
Right.
It's difficult, so we need to create a definition for the inverse function. So that is the topic of this class. Then the other is to identify what is the inverse of the function. Remember, I will put here, we have the inverse of a function is always the reflection of the function with respect to the line x is equal y. We will see how to do this graph. Okay, let's go back to our notes.
The Germans didn't even know you could swim in paper. Texted me later in this.
He did.
Maya wanted to wear like a nice outfit. I think she didn't know it was a swim for y'all. Let her know that.
Yeah. I'm gonna go.
Okay, we have logarithms.
He's not allowed to.
What?
Cause I'm in trouble. He's been in and everything.
Oh.
Logarithms. The equation defining the inverse of a function is found by interchanging the value of x and y. That was the first step to find the inverse function. In this case, for the function y is equal a to the x, please highlight this part. You can, we can take this equation is the one that we are going to analyze, is the exponential equation. The first step to change for finding the value of the inverse is to interchange the value of x and y. So y becomes x and x becomes y. This is the inverse function. But now let's see. Here y is the exponent to which a must be raised in order to obtain x. To this exponent we call the logarithm.
Wait, what?
Is there. Here y is the exponent to which a, everything is here, you can highlight. We call this exponent a logarithm, symbolized by the abbreviation log, log. The expression log of x represents the logarithm in this discussion, the inverse function. The number a is called the base of the logarithm and x is called the argument. This is x is called the argument that is in here or here. Is read the logarithm with base a for x, or logarithm of base with base of x with base a. Now we have two expressions. Let's see. It sounds a little bit confusing, but look at that now. We have two equivalent expressions. We know the exponential function. Now we are going to write the same by using logarithms. Okay. For all real numbers, we have these two equivalent expressions. Y is equal log of on base A of x. This can be written in this way. X, which is the power, this number will be equal to A, the base, to the value of y. So we call this the power. The value of y will go to the power here. The base is the base of this exponential function. These examples. I will do the first one, then you help me with the second one. And I will put here the expression.
No, you.
So let's see. I have logarithm on base A of x is equal y. So what is the base in this part?
8,
What is the base?
2.
2 is the base, so let me put the base as 2. Okay? What is the power? The power is the number. This logarithm is equal to the exponent. So this exponent is 3. So 2 to the 3 must be equal the argument, which is 8. Easy. Did you see? 2 to the a is 8, 2 to the 3 is 8, equal 8. So we write this expression in this form.
Okay.
Okay, Mr. Faisal,
Yeah.
help me with the second one. What is the base? Step by step. What is the base in this case?
1/2.
1/2. Let me put the base here. Always we write base. This is the base. Log of the base. So it will be 1/2.
Would be that to the power of that equals 16.
It's not the square root of 16 equals 4.
No, it shouldn't be. It should be 1/2 to the power of -4.
Negative 4. Always this number, which is the logarithm is equal, is the exponent. Can you see? Now negative 4 is the power. Negative 4 is the power. Negative 4 is equal to the argument.
So I'll just put 0.5.
The argument is 16. You can put 0.5, but let's see at this moment. Let's visualize what is the base, what is the
Is
height.
that correct?
That's correct.
1/2 to the power of -4 is 2.
Yes,
Oh.
yes, that's correct.
That is not smart.
Mhm. Okay.
Ms. Lauren,
Okay.
okay, try this one.
Okay, a big 10.
Base is 10.
And
What is the power?
5.
5 is equal to
100,000.
100,000. Look at that, this is easy to see. Because in this case, 10 times 10 times 10 times 10 times 10 is 100,000.
Right.
You will see this a little bit difficult, but 1/2 times 1/2 times 1/2 and times 1/2 is 1/16 to the -1, which will be 16. Okay, next one. For the next problem, we have the exponential version, the exponential form. We need to rewrite in the logarithmic form. Face it.
Yeah.
What is the base?
Wait. 3. Log
The base
3.
is 3 because this base has the power.
Yeah.
So will be this is the base, 3 is the base.
I don't write log 3.
Of course, we need to put log on base 3.
And then 1/81.
1/81 is the argument.
Yeah.
So 1/81 is the argument,
Is equal to -4.
is equal to -4. Great. Great job. Okay. Lauren, next one. I will put logarithm on base something of the argument is equal to the power.
Log 1.
Log of
1.
where the one?
Under by log.
Here?
Yeah.
No.
No, 5 is right there. 5.
5 because the power is 5. Sorry, the base is 5. This is 5. What is the argument?
5 equals. No. 5 equals 1.
of 5. So this can be 5 here, which is this 5 is equal to the power. Always the exponent is in the other side. Okay, last one. Facer?
Log 3/4.
Log on base 3/4.
Base 3/4 exponent 1
Exponent 1.
equals 0. No, not, but
No,
yeah. Oh, argument. Argument
argument
1
1
and then equals 0.
equals 0. Yes. As you will see in the graph, when you see the graph of the function log of x, log of 1 is equal to 0. You will see that. Okay? So you will have problems in your homework for changing.
Is this
from
our
the-
homework?
It's like that. 4 problems, but this is the first step for solving equations, logarithmic equations. This is the first step. Changing from logarithm to exponential, because you know how to solve exponential functions.
Right.
Before we go to the next page, some notations. The common logarithm. If you have logarithm on base 10, let me put any number of a variable here, of x is equal y, this is same to write log of x is equal y. Do you remember the square root? The square root has an index which is 2, but we do not write the 2. When we are using logarithms, the number 10 is not written in here. And that is called the common logarithm. Okay? That is the common logarithm. You have in the definitions. So if you see the number is not here, that means that is the number 10. Okay? Now, what about if we have the number e? Logarithm, another, on base e of x is equal y. That means instead of writing the number e, we use the letter ln. Let me put it in a different color. It's natural logarithm. ln is the same to put logarithm on base e of x is equal y. These are special cases of logarithms, and we are going to work with these bases on the next programs. Okay, so far, questions for the next part. This is the best way to remember this change between the two forms. Be focused on the exponent and the base. Exponent and the base exponent. That's it. And the number x is the argument. The argument goes outside. Now, this is the first step to solve logarithmic equation. In this case, this is an equation. In one side, we have the value of log on base x of 827 is equal to 3. The value of x can be the base, can be the argument, or can be the power. You can find the x anywhere. But the idea is how to solve. First step to write in exponential form. Please help me with that. What will be the first step?
X is the base.
Step. So x is the base. What is the power?
Is it 8 over 27?
The power?
Is not 8 over 27?
No. The
3?
power is always the number x to the 3 is equal to 8 over 27, the argument, 8 over 27. Look at that. You have now a simple equation. Is this an exponential equation, Lauren?
Yes.
No.
Why?
Why? Is the variable on the exponent?
Is the variable on the exponent? No.
No, the variable is not the
Exponent's
exponent.
on the variable.
The exponential equation, remember, is when the variable is in any part of the exponents in any side.
My bad.
Yeah, you got it. So how to solve this equation? We just take the inverse operation, which will be taking the cube root in both sides.
And when you take the cube root, you don't have to do plus or minus, right?
You don't have to do plus and minus, because only in the quadratic equation you have minus 2 times minus 2 is equal 4, or 2 times 2 is equal 4.
Forgot to do these.
Where did you get the E2 because?
Forgot to do these.
So what do you do here? You cube, cancel the cubes.
Is it 2 over 3?
So you have x is equal to,
Melvin peanut fingers.
what is the cube?
Like, we're thinking
The
egg
cube root of
shock.
8.
That is weird.
Face it.
2.
What number makes exactly 2? Value is 2 because 2 times 2 times 2 is 8. Divided by 27, the cube root of 27.
3?
Why?
3 times 3 times 3 is 27. Is it a nerve?
Happy face.
Do you have a nerve right here?
I don't know. Do you have nerves in your fingers up here?
Yes.
You do?
Oh,
Mhm.
look at.
Could be a nerve.
Okay, next problem. Let's see if the next problem is exponential function, exponential equation.
No.
No.
Let's see. First step, Lauren.
Base is 4
Basis 4
raised to the 5/2
raised to the 5/2. It is a rational exponent.
equals
Is equal to
x.
x. Look at that. So, is x isolated?
Yeah.
Yes.
Yes.
So we always have
Can
to
we find-
isolate x?
Can we find this value?
Yeah.
What is the value?
It's like the square root of 4 to the 5th power.
What? How'd you do that?
Which is, what is that?
How do you know what to do?
Huh?
Isn't it already solved for x?
Yes, because it's 4 to the
5th power. Yeah, the 5th power. And
5
square
over
root.
2
5 over 2.
Oh,
To
wait.
the 5 over 2. That's equal to
x. Oh wait, what?
32.
Oh, you just solved it? How do you solve that again? Like, how do you like literally solve
Okay,
it?
let's see.
If
How
you,
literal?
if you didn't have a calculator, how do you solve it?
Oh,
I thought you-
easier.
I thought you
Easier
could
than
write
with the
that
calculator. Look at that. Remember, 5, I will put 4.
Yeah.
This is same to write to the 1/2.
Oh,
as-
wow.
Yeah,
Okay.
square root, I thought.
And then this is,
I'm not
to
going,
the 5.
I'm going crazy then.
aha. Now, what is this same to put the square root of 4?
Yeah, okay, I know I'm not crazy.
What?
Yeah, you're not crazy.
Then. I don't know.
The square root of 4 is the same thing, the 5. What is the square root of 4?
2.
2. What is 2 to the 5?
Did we learn this?
2 to the 5 is 5.
Oh, that.
Wait.
That's not right. Wait. 2 times 2,
Times 2.
4,
Times 2. Times 2.
16, 32.
Aha. And we have studied that, remember? It's there.
I don't remember doing that.
A to the m divided by n is equal
Yeah,
to the
that's
square.
like when we changed the forms of like. Hazel, you totally know how to do that.
We did that this year?
Yeah.
Yes, it's easier. man.
Like when you write like something to the 1/2 power and then you put it in the.
The index. The index. It's
Oh,
there.
no.
You have to remember that. Hazel.
I'm gonna fail
You
this
have to
exam.
remember that. Okay, the last problem. Okay, this was not a exponential function, equation. Maybe the next one.
Yeah.
Okay, who wants to do?
Hazel.
Basil, thank you.
Thanks, Lauren. 49 at
49 is the base.
Yeah.
Okay, I will put 49 as the base.
49 to the power of x,
to the power of x. Oh, now look at that. Is equal to
cube root 7.
the cube root of 7. Now we have the power is a variable. So this is a exponential equation. How do we solve this function? This is the question.
Square root of 49.
Don't you have to get 49 to be 7?
Exactly. We put the same base in both sides.
How do you all remember this?
We did that
We
yesterday.
did that yesterday. Hazel.
Yes.
Right.
Yeah, we did that yesterday. And yesterday you solved 3 problems here in class.
And is it the cube root of 49? No.
Let's see. So 49. How many times multiply 7 you get 49? Of course, 2.
Alright.
So you have 7 squared to the x. Now, the same change between the radical to the rational exponents. You have 7 to the what power?
7 to the.
1 over 3.
1 over 3.
Bless you. Oh my
Bless
god,
you.
Basil.
Thank you.
Let's you face it.
Oh, it scared me too.
Okay, so now how do we put 7? 7 to
You
the 2 times x.
Yeah, equals
Oh,
1.
look at that. What happened?
You set the exponents equal now.
Great, now you remember.
Yeah.
I
now.
told you. So you have 2x is equal to 1/2.
1/2.
Oh, 1/3. Thank
Where-
you.
oh.
Thank you.
What's 1/2 divided by 2?
This is 1/3 also. Yeah, thank you.
Yeah,
One third.
y'all been
Great, great. So what is now what? How do we sort this part?
1/3
Easier.
times 2 divided by 2.
Or divided by 2, we divide by 2, divided by 2 will be x is equal 1/6.
Remember that? Okay.
And that is a happy face. Very happy face.
Are we done?
This is just a question. So what you do is you graph, you change to exponential, then you solve the exponential equation.
Okay.
Finally, we have the graph. Just the definition we will start doing the homework in a
Okay.
minute.
Cool.
Where's that? So look at that. The function, now we define the function y or f of x, which is the same as equal logarithm base 8 of x. Let's go to my GeoGebra. Inverse. You have the point 0, 1 here. The inverse is the point 1, 0. Let's choose another point. This point here, which is a little bit 0.84. The point here will be 4, 1, 2, 3, 4, 0.8. This is the reflection over this axis. And it doesn't matter what kind of base we have, if that is increasing. Remember, we focus on the red graph. On the red graph.
That's a mirror or reflection?
It's a mirror.
Okay.
It's a mirror. Look at that.
That's a mirror?
Yeah, look at that. It's a decreasing, decay.
Yeah.
Now this other is the mirror. The point 0, 1 is the point 1, 0. Now this point 2, 0 almost 0 will be 2 almost 0 here.
Yeah.
Yeah? Okay. Okay? Sometimes you will have the exponential, you need to solve a logarithm because that is easier.
Right.